Hi, I'm Cheryl Leach. In this problem, we're asked to find the rate of change of x with respect to p. Well, that's a derivative, so let's get started. I'm tempted to dive right into this and take the derivative. However, let's back up and make sure we're doing what we think we're doing. Recall that we're supposed to be finding the rate of change. So I was correct in saying that that's the derivative. But we have to be careful here because what are we taking the derivative of? We're taking the derivative of x, and we're taking it with respect to p. So that means when I take the derivative, I want to treat p as the independent variable. That's not the way my equation is set up. And that's okay, but I'm going to need to use implicit differentiation to do this one. All right, so as I look at this, I know that I want to find dx dp. Well, I mentioned implicit differentiation because I really don't want to solve that equation for x. So I'm ready to get started, but boy, that's going to require using the quotient rule, and it's going to get fairly complicated. I think I may do a little bit of algebra rewriting to see if I can help myself. What I'll do is I'll multiply both sides of that equation by my denominator. So I'll have p times the quantity 0.00001 x cubed plus 0.1x, and that's going to equal 2 when x is greater than or equal to 0. All right, well, I've avoided the quotient rule now, but I'm going to need the product rule to take the derivative of that left-hand side. Let me do one more algebra rewrite. I'm going to divide both sides by p. So I end up with, on the right-hand side, 2 divided by p, which is also the same thing as 2 times p to the minus 1 power when x is greater than or equal to 0. So all I've done is a little bit of algebra rewriting, but now I can go ahead and use my differentiation rules without some of the more complicated rules like the quotient and the product rule. So I'll differentiate both sides. Remember, I'm differentiating with respect to p. So the derivative of 0.00001 x cubed will be 0.00003 x squared, and the derivative of x with respect to p is dx dp. Now I need the derivative of 0.1x, which is just going to be 0.1, and the derivative of x, again, don't forget, is dx dp. On the right-hand side, I just need to take the derivative of 2p to the minus 1 power. So minus 2p to the minus 2 power, and again, x is going to be greater than or equal to 0. Differentiation is done, but I want to collect all my dx dp terms on one side, and actually, that's already done for me. The next thing to do is to factor out the dx dp. So with a little bit of factoring, I end up with dx dp times my quantity equals a minus 2p to the minus 2 power. Finally, I'll divide both sides by that quantity that's inside my parentheses. And so dx dp will be minus 2p to the minus 2 power all over that quantity that's in parentheses. The only other thing you might consider doing is writing that p to the minus 2 using a positive exponent. All that will do is take the p to the minus 2 and pull the p into the denominator, and so it's p squared times my quantity. And now you have the rate of change of x with respect to p. I hope this was helpful. Thanks.